Awesome. Let's get through a couple of examples with these complex numbers, all right? So what we're going to do is in this first question, we're taking z over w, and we want to rewrite it in just the normal complex, the complex number format. Now, the reason for this is because then we can compare it with other complex numbers and know if it's equal or not. So we're going to take z, which is 3 plus 2i, and we're going to divide that by 4 minus i. Now, in order to get rid of this complex number on the bottom, complex numbers are very similar to many other things. We don't like decimals in the bottom. We don't like exponents in the bottom. We don't like irrationals, the square roots. We don't like those in the bottom. Okay, so similarly, we don't like to have imaginary numbers in the bottom. So in order to get rid of an imaginary, of course, we multiply by its conjugate. So we're going to multiply by the conjugate, 4 plus I. Now, when we do that, of course, on top, we're going to have 12. 3 times I will be plus 3i. Then we're going to have 2i and 4, so plus 8i. And then 2i times I. I times I, of course, is I squared, which is negative 1, so minus 2. On the bottom, we're going to have 4 times 4, which is 16. And then 4 times I will be plus 4i minus 4i. Those will cancel out, so negative I times I will then be negative I squared being negative 1, so plus 1. And so now we can just simplify, and when we simplify, we end up with 12 minus 2, which is 10, 3i plus 8i, which is 11i, and then all over 16 plus 1, which is 17. Now to put this in the final format, that'll be really easy, because then we just go 10 over 17 plus 11 over 17i. And that's all there is to it. No problem, huh? Boop! Example number 2. Here we go. We got x plus yi times 2 minus I equals negative I, and x and y are real. Determine the values of x and y. Now, you can tell with two variables, you could possibly do something with simultaneous equations, but we don't really want to have to do that because we've only got one equation here. So much better would be to be able to use that idea of a plus bi equals c plus di if a equals c and b equals d. So if I can get rid of this 2 minus I and get the other side to look like this format right here, then I would know what x and y are. And so that's what I'm going to set about doing. And so first I'm going to get rid of that 2 minus I. I'm going to divide both sides by 2 minus I. So I'm going to have x plus yi equals negative I over 2 minus I. And then in the previous question, we learned how to get rid of that I on the bottom. Yeah, problem. It does mean, well, we know that that can't be 0 because I cannot be 2, so that's not really a problem because we didn't divide by 0. We know for a fact we didn't divide by 0. So now we're just going to take this side and we're going to multiply by 2 plus I over 2 plus I. I can do that because anything divided by itself is 1. And so on the left-hand side, I still got x plus yi equals, now on the top I'm going to have negative I times 2, so negative 2i, and then negative I times I will be negative I squared, which is the same thing as plus 1, all over 2 times 2, which is 4, negative I times 2 will cancel out, negative I times I is negative I squared, which again is plus 1, and so there we've got negative 2i plus 1 over 5. We simplify, so therefore we have x plus yi. No, sorry, that's not a subscript. It's just yi. It sounds like SpongeBob. Okay, anyway, then we have negative 2 over 5i plus 1/5, and therefore x equals 1/5 and y equals negative 2/5. Because I've gotten it in that format, the number in front of the I has to be equal to the number in front of the I here, and then the number by itself has to be x. And so we've got the two to match up. Because the two are equal, therefore we have solved for x and y. And we're on to example number 3. So with example number 3 here, we now have x plus 2i times 1 minus I equals 5 plus yi. Now, again, I look at this, I say, this looks kind of like that c plus di thing right there. All right, so if that's c plus di, then if I can get this side to look like a plus bi, then I am in the money. So we're going to try to set that up. Now, I notice that x is a real number here. y is in the imaginary part. Now that's really nice because that means if I can keep it that way, where x stays in the real realm and y stays in the imaginary realm, then it'll be easier to solve for x and y later because the real parts will be x and the imaginary parts will be y. That's just wishful thinking, so we'll just see what happens from there. So what I'm going to do is I'm going to go ahead and FOIL this because it doesn't do me any good to have it in the two binomials there. So x times 1 is x. X times I, yeah, wishful thinking. So minus xi, 2i times 1 will be plus 2i, and then 2i times negative I will be minus 2i squared, still equal to 5 plus yi. Of course, I can simplify the I squared, so I'm going to have x minus xi plus 2i, and then minus 2i squared will turn into plus 2. Now what I'm going to do is I'm going to rearrange this a little bit because I want the real pieces together and the imaginary pieces together. So I'm going to rewrite it. I'm going to go x plus 2, so that's the x plus 2, and then I'm going to go minus xi plus 2i equals 5 plus yi. Now the whole point to that is that now I have x plus 2, which is the real piece, and then I can factor out an I here, so then I can go plus I times negative x plus 2 equals 5 plus yi. So again, the x plus 2 is the real part. The I times negative x plus 2 is the imaginary part. And so I can write two equations essentially where x plus 2 equals 5 and where negative x plus 2 equals y. I can easily solve for x right here, so subtract 2, x equals 3, and then I can solve for y over there because now that I have x equals 3, it's just negative 3 plus 2, and so negative 1 equals y. We have managed to solve for x and y. Ta-da! Done with this video. Good luck with your homework.